Welcome to the DIY Honda Garage channel. DTC B12C6 indicates an electric steering lock switch circuit failure in the 2017 to 2023 Honda Accord. This diagnostic trouble code is related to the power control unit, PCU, which is vital for regulating electronic components in the vehicle. The electric steering lock switch control is responsible for securing the steering system, and when a failure occurs, it results in the inability to lock or unlock the steering. The switches, labeled C and D, are located near the ignition system connectors. Hence, any malfunction can impair steering functionality, especially in terms of safety and accessibility. Understanding this code is critical for ensuring the steering system's integrity and responding quickly to maintain driving safety. DTC B12C refers to a malfunction in the electric steering lock switch C and D monitor circuit. The electrical steering lock system plays a crucial role in ensuring that the vehicle's steering wheel is secured when the vehicle is off. This prevents unauthorized use and enhances the vehicle's theft deterrent system. These switches are typically found within the steering column's electronic control systems, connecting to the ignition circuit to relay necessary status information to the power control unit. When the monitor circuit fails, it could result in erratic behavior of the steering lock mechanism, potentially leading to safety issues while driving. Understanding the specific location and function of these components is important for effectively diagnosing the issue and carrying out repairs. Several factors may lead to the triggering of DTC B12C6. Firstly, loose or poor connections can disrupt the electrical signals necessary for the electric steering lock switches to function correctly. When the connections become compromised, it may result in intermittent faults that will trigger the DTC. Secondly, both short and open circuits within the wiring harness can lead to failures in the communication between the switches and the power control unit. A shorted wire may cause continuous grounding, while an open circuit can prevent signals from reaching the PCU altogether. Lastly, a malfunctioning steering lock switch itself may also be the root of the issue, requiring replacement as part of the diagnostic process. The symptoms associated with DTC B12C6 can significantly affect the performance and usability of the Honda Accord. One primary symptom is the illumination of warning lights on the dashboard, alerting the driver to a malfunction within the electrical system. Additionally, drivers may experience difficulties in turning the steering wheel, which can raise safety concerns and impact maneuverability. Another potential issue linked to this DTC is a malfunctioning ignition system. The steering lock's failure can directly interfere with the ignition process, leading to starting problems. Being vigilant for these symptoms is key for timely diagnostics and effective repairs, ensuring the safety of both the vehicle and its occupants. In the first troubleshooting step, the Honda Diagnostic System, HDS, is utilized to clear any existing DTCs. Clearing DTCs allows for the re-evaluation of the vehicle's systems. After clearing, the vehicle should be cycled through the off, lock, accessory, on, and again, off, lock modes a total of 10 times to reset the systems. This repetitive cycling prepares the system for a fresh diagnostic check. Following this procedure, the technician should check again for the existence of DTCs. If DTC B12C6 is present once more, it indicates a persistent issue that necessitates further investigation. If not, it may suggest an intermittent fault that could be related to loose connections, thus prompting a closer inspection of wiring and connectors. The second step involves checking the parameters regarding the electrical steering lock switch C and D using the HDS. During this check, the current statuses of the steering locks will be assessed to confirm they are both in the off position. The technician should analyze the data list values provided by the HDS interface. If both switch C and D show values as off, it points towards normal operation, and the process continues to step 8. However, if either switch displays a different status, it prompts further troubleshooting, indicating potential issues with the switches or their associated wiring. Understanding these parameters is vital to isolating the root cause of the problem. In this third step, the diagnostic checks are repeated, but the focus is solely on electrical steering lock switch C. This involves utilizing the HDS again to assess the current status of this particular switch. The technician must confirm that the switch C status is showing off, consistent with the expected operational condition. If the data list indicates that switch C is functioning properly, the procedure will proceed to step 9. However, if there is a status indicating otherwise, it suggests a malfunction that necessitates immediate attention on the switch or the wiring related to it. This methodical approach allows for pinpointing specific faults within the system. Step 4 entails examining the parameters for electrical steering lock switch D, following a similar procedure as steps 2 and 3. The HDS must be employed to verify that the status of switch D is off, as this is vital for the proper functionality of the steering lock. If the data confirms that switch D also displays an off status, the procedure will proceed to the next troubleshooting step. However, should the check reveal that switch D is not off, it indicates a fault that requires closer inspection of the switch or the associated circuitry. Maintaining these testing protocols helps to maintain the accuracy of the diagnosis, ensuring that issues are resolved efficiently. In troubleshooting step 5, the focus shifts to checking the electrical steering lock switch C line for continuity. The vehicle must be placed in the off lock mode to perform this test correctly. The technician will first disconnect the 12P connector associated with the electric steering lock. This allows for a thorough continuity check between designated test points. The first test point is terminal number 9 from the 12P connector, and the second is the body ground. By confirming the presence of continuity, it can be determined if the wiring is intact. If continuity is confirmed, the procedure proceeds to the next step. If not, it points towards an issue with the wiring that must be addressed, leading to a potential repair need. The sixth troubleshooting step involves checking the continuity of the electrical steering lock switch D line. Just as with the previous step, the vehicle must be in the off lock mode, and the 12P connector should be disconnected. In this test, the technician will evaluate continuity between test points. The first test point is terminal number 10 of the 12P connector, and the second is the body ground. This procedure assures that the ESL SWD circuitry is intact. If continuity is realized, then the wire is functioning correctly, and the next steps can determine the origin of the DTC B12C6 indication. If no continuity is detected, it suggests further inspection and possibly replacing the steering lock, as it indicates a wiring disconnect. Step 7 requires checking the electrical integrity of the electrical steering lock switch D line once again. At this point, the technician will disconnect the body control module connector C66P. The focus of this continuity test is still on the D line, specifically terminal number 10 from the 12P connector. The second test point will be connected to ground. This testing measures electrical connection integrity and is critical for diagnosing potential faults in the wiring. If continuity is detected here, it suggests that the electrical steering lock switch D is functioning as intended. If not, the next step would involve repairing any short to ground detected within the wiring before taking further steps. In the 8th step of troubleshooting, the focus is on the ground wire associated with the electric steering lock system. The vehicle needs to be in the off lock mode, and the 12P connector should be disconnected. The technician will then check continuity between the designated test points. In this case, test point 1 corresponds to terminal number 7 of the 12P connector, and the second test point is set to body ground. This process ensures that the ground connection is functioning correctly. If continuity is present, it indicates the ground wire is operational, and the next step would be to replace the steering lock. Conversely, if continuity is not present, it signifies an issue, such as an open circuit or high resistance that necessitates repair. Moving on to troubleshooting step 9. The goal is to check the wiring associated with the electrical steering lock switch C line under operational conditions. The vehicle should be switched to the on mode while keeping the 12P connector disconnected. The technician will then measure the voltage between the two designated test points, seeking to confirm the presence of battery voltage. This measurement plays a significant role in determining the functionality of the wiring leading to the ESL SWC. If battery voltage is confirmed at test point number 9, it suggests that the ESL SWC wire is operating correctly, allowing for the next step to recommend replacing the steering lock. If no voltage is detected, it indicates a deeper issue requiring further investigation in Step 10. Step 10 focuses on performing another voltage check, but this time for the electrical steering lock switch C line, while ensuring the body control module connector C66P is also disconnected. The vehicle must be in the off lock mode during this evaluation. The technician will check to confirm continuity between the designated test points. Detecting continuity here suggests that the wiring connected to ESL/C is intact. If continuity is confirmed, the technician should recommend replacing the body control module, as it represents the next potential point of failure in the steering lock system. Failure to find continuity would indicate further issues within the wiring itself that must be repaired. In troubleshooting step 11, the emphasis shifts towards the electrical steering lock switch D line. The procedures mirror those previously undertaken, aiming to verify the functionality of this switch. The vehicle must be switched to the on mode while the 12P connector remains disconnected. The technician will then measure the voltage at specified test points to establish whether battery voltage is present. If battery voltage is confirmed, it affirms that the ESL SWD wire is operational, leading to the recommendation for steering lock replacement due to potential internal circuitry failure. If battery voltage is not present, the technician will proceed to the next step for in-depth investigation. Step 12 mirrors the previous checks for the electric steering lock switch D line, but requires an emphasis on checking continuity of the corresponding wiring. After ensuring the vehicle is in off lock mode and the body control module connector C is disconnected, the technician will inspect for continuity between designated test points. This process aims at confirming the integrity of the wiring leading to switch D. Should continuity be detected, it suggests the wiring is functional, prompting a recommendation for replacing the body control module. If continuity fails, it indicates an open circuit or high resistance problem within the wiring that should be repaired accordingly. The final troubleshooting step focuses once again on checking the continuity of the electrical steering lock switch C line after disconnecting the body control module connector C. This check must be performed with the vehicle in off lock mode. Continuity between the specified test points provides valuable insight into the integrity of the wirings, linking the steering lock system back to the body control module. If continuity is present, it points toward identifying a short to ground somewhere within the wiring that will require repair. If no continuity is found, it suggests a need for a deeper evaluation of the entire wiring harness, leading to both the switches and module. Final repair verification is essential after completing all necessary troubleshooting steps for DTC B12C6. To ensure that all repairs have been executed properly, the technician must carry out a thorough assessment of the steering lock system post-repair. This involves conducting a full test drive to validate the performance of the steering lock under various driving conditions. During this process, monitoring any potential warning signals from the instrument panel ensures that no electronic faults are still present. Finally, a follow-up scan with the Honda Diagnostic System, HDS, must be conducted to confirm that there are no lingering DTCs, essentially proving that the problem has been resolved effectively. Preventive maintenance is a proactive approach to mitigate future occurrences of DTC B12C6. It is advised to schedule regular checks of the electrical connections associated with the steering lock system. This ensures that any loose wires can be detected early before they can escalate into a DTC return situation. Additionally, routine diagnostics utilizing the Honda Diagnostic System, HDS, can help catch minor issues before they become more significant problems. The condition of the wiring harness also deserves attention. Regular visual inspections can reveal signs of wear or damage that might lead to operational failures in components. Implementing these preventive measures contributes significantly to maintaining a reliable steering lock system and enhancing overall vehicle safety. In conclusion, understanding DTC B12C6 is essential to ensuring the integrity and safety of the Honda Accord steering lock system. This diagnostic trouble code represents a significant concern that can have serious implications for driving security if not addressed promptly. Thorough diagnostics and methodical troubleshooting steps are vital to accurately identifying and resolving issues related to the electric steering lock switches. Additionally, implementing a regimen of preventive maintenance can avert future complications, emphasizing the importance of connection integrity and wiring condition. By staying proactive, drivers can maintain the reliability of their steering systems, ensuring safety on the road. Please like and subscribe to the channel. See you next time!